Okay, first is any base taken to a power of 0. It's always going to have a value of 1. The only exception is that a cannot equal 0 to start with. Your base, any non-zero base taken to a power of 0 is always has a value of 1. Okay, and then the second rule here is when we multiplied two exponents with the same base, we added their powers. When you divide two exponents with the same base, you're going to subtract their powers. And now let's take a look and see why this is true. It should make sense based on what we talked about in the first slide. If we were to take this original expression, we have a to the m, and let's say we move this base, the base from the denominator up to the numerator. What would we have to do to its power to move it up, or to indicate that it belongs in the denominator? Have to change it to a negative, right? So this right here, this fraction can be represented in this form as well. And then if we applied the rules for the multiplying exponents with the same base, we would add their powers. So we'd get m plus a negative n, which is what we see up here in this rule. So you can just use the shortcut here. You don't need to go through this process every time. Just when you divide two exponents with the same base, you subtract their powers. All right, what I'd like you to do here, as these two examples I would like you to try. All right, in looking at these problems, again, do keep in mind that you need to be able to handle these without using a calculator. Okay, so if we evaluate, here we have, in part A, we have repeated multiplication. 3 times 3 times 3 times 3. You can imagine grouping these together if you want to. 3 times 3 is 9, so 9 times 9 gives you a total of 81. Okay, what about B? When we look at B here, here the base was very clear. The base was a 3. What's the base in this second example? The base of that power 4, is it a 3 or a negative 3? It's just a 3. Okay, so the base is the number that's going to be repeatedly multiplied. If there's no grouping symbols around it, the negative simply indicates change of sign. Okay, and remember, order of operations says you do grouping symbols first, then exponents, then multiply and divide, and then add and subtract. So the exponents come before this multiplying by the change of sign, by the negative 1. Okay, so when you multiply this, you have your negative, and then it's 4 3s. So that negative is still going to stay out front. So you get a negative 81 for your answer to B. All right, if we look at C, now what's our base of the power 4? Now the base is that whole thing, negative 3. So now, as you look at this, you're going to have negative 3s multiplied by themselves 4 times. So now every two negatives cancel, and so you get your overall product is positive. So here you wind up with a positive 81. Okay, be careful and distinguish between forms like B and C, and to avoid common mistakes. Okay, and then finally the 1/3 to the power of negative 4. So if we apply this negative, the property of the negative power, we're going to take this fraction 1/3 and flip it. So what's the inverse of 1/3? Just 3, change the sign to 4, and we saw over here, 3 to the 4th is 81. All right, let's look at this second row. Okay, in the second row, looking at E, our base with the power 0 is the whole expression 5t. So what do we know its overall value is? Just 1. Anything that's non-zero, any base that's non-zero to the power of 0 will always have a value of 1. Okay, if we look at part F, here we have this power of negative 1. The base that power applies to is the whole product, 5t. So that entire product gets moved to the denominator. And we take it to the power of, we change the sign to 1. We don't need to write a power of 1, so we can just leave it in that form. Right? In G, the power of our exponent with a base t, or with a power of 0, is what? 5t or just the t? It's just the t. So really we have 5 times t to the 0, which has a value of 1. And so our overall answer is just going to be 5. And then our final example here, 5t to the power of 1. Again, a power of 1 does not need to be written, so we just leave it the variable itself. And so 5t would be our answer for H. Any questions on that set? Right, if we look at this sample problem number 4. Okay, when you're dividing exponents with the same base, you could use the property exactly as it's interpreted. So we could take we notice a common base, so we can write that common base and subtract powers. So 6 minus a 2 leaves us with x to the 4th. So you could apply the properties exactly as it's written. Now, probably what most of you would do on this would be to cancel factors. You can also think of these as canceling factors. So if you look at this fraction as it sits, you have 2 x's in the denominator that cancel with 2 from the numerator, leaving 4, which gives you your answer x to the 4th. Okay, so you can cancel factors or you can apply the properties. All right, if we look at B, again, similar thing, that you can apply one of 2 rules. You can directly apply the rule where dividing exponents with the same base, you copy down the common base and subtract their powers. So 3 minus a negative 7 becomes 3 plus 7. So you get t to the 10th. Okay. Or what you could do is you could rewrite your negative power. So if we move this whole base of t up to the numerator, change the sign of its power, and then just apply the rules for this. Multiplying 2 exponents with the same base, you add the powers. T to the 3 plus 7 gives you t to the 10th. Okay, E is the same as, or problem C is the same. You have a common base, so you can either subtract their powers. So e to the minus 5 minus a negative becomes a plus 7, netting you e to the positive 2, so e squared. Or you could move your base e up to the numerator, change the sign to positive, and then add their powers. So e to the negative 5 plus 7 still gives you e to the 2, or e squared. Okay, and then this last example here, if we applied the properties directly, we have division of exponents with the same base. So we're going to keep that common base and subtract the powers. So negative 2 minus a 2 gives you h to the negative 4. Okay, and this has multiple forms. You can write it using a positive or the positive power as well. That would entail moving your base of 4 to the denominator, changing the power of it, or the sign of its power. So either of those forms would be okay for that one.